Okay, in this video, we're going to look into the IBUS radio protocol used in the RC model industry and how to interface the IBUS receiver, which you can see here, to a microcontroller so we can decode the control command packets sent by the transmitter, and I'm using an FS-I6 transmitter, to the receiver. Now the IBUS protocol is used by FlySky. It's a serial protocol, it's UART compatible, and can control up to 14 channels or functions using one wire. Now in my case I'm using a 6-channel receiver and a 6-channel transmitter. Now in the early days we'd use PWM, we'd plug our servos into the receiver, you can see here, the 3-pin connector. But in my case I'm using IBUS, which is a single wire output. So you can see the connector is plugged into the IBUS port. So the black wire is a common ground, the red wire is plus 5 volts, and the white wire is the IBUS output, serial output. So we hook up the white wire to a microcontroller UART, and we could decode the control functions coming from the transmitter. Okay, next, I want to check that my transmitter is actually putting out RF power. So I have a field strength meter, and I'll turn on my transmitter, and I'll get an indication if I'm putting out any RF power, and I'll turn it on. There you can see I'm getting full LEDs, full bars, so I know my transmitter is working. So the next thing we have to do, we have to bind the transmitter to the receiver. So I power up my receiver with my bind jumper connected. Then I hold down my bind button and I turn on my transmitter, and now my transmitter will be bound to my receiver. Okay, next I'm going to check out the operation of my receiver. Now I have it connected up to an FTDI module, which you can see on my breadboard. And the FTDI module is jumpered for 5 volts, so it's actually powering the receiver through the black and red wires. And then the white wire is connected up to the RX input of the FTDI module. Now you notice the LED on the receiver is solid, so it's bound to the transmitter, and we have data now flowing on the white wire into the FTDI module. So next I'm going to get an oscilloscope, I'm going to hook it up to the white wire, and we'll have a look at the waveforms coming out of the receiver. Okay, next I have my scope connected up to the IBUS serial output, which is the white wire, so we could have a look at the waveforms coming out of the receiver. You notice we have some data bursts or data packets, and they're about 3 milliseconds in duration, and they're happening about every 5 milliseconds. So every 5 milliseconds or so we get a data burst of 3 milliseconds, and inside that data burst there's 32 bytes of data. So next we're going to have a look at those 32 bytes of data and decode them. Okay, every 5 to 10 milliseconds we're going to receive a data packet, which is about 3 milliseconds in length. And inside that data packet there are 32 bytes. Now it starts off with a header, which is 2 bytes. So hex 20 and hex 40, that starts the packet. Then we have our channel data from channel 1 to channel 14. Now each one of the channel data values are 2 bytes or 16 bits. And the values are 1000 to 2000. Then we have our checksum, which is 16 bits or 2 bytes. So the channel data from channel 1 to channel 14, that's 28 bytes, plus a checksum, that's 30 bytes, plus the 2 header bytes, that's 32 bytes. Now the channel data comes in a low byte and a high byte, so we have to flip it to get the right value. So next we're going to run a serial terminal program, and we're going to have a look at this bit stream coming out of the receiver. Okay, I have RealTerm up and running on my computer, and it's connected to my FTDI module, which is monitoring the IBUS data line from the receiver. And you can see the data packets coming in, and I got my baud rate set for 115.2K baud. I'm on COM port 6, that's my FTDI, and on my display I'm using hex space, that's my hex space format. Now I have 2 sync bytes. I have hex 20 and hex 40. You can see I'm set them up as my sync bytes. So those are my header bytes, and if I take away the sync, you can see the data gets garbled. I'll put back the sync and makes the data come out properly. Now hex 20 and hex 40, you can see they're on their own line. Then underneath there is all the channel information, all the channel data. So if I turn on my transmitter and I'll go to channel 1, I'm moving the joystick. Channel 1, you can see the bytes moving. This is channel 2. This is channel 3. You can see the bytes moving. And there's channel 4, and then there's the 2 pots, channel 5, and this is channel 6. Now 7 to 14 isn't being used because it's only a 6-channel receiver. So if you look at the data, it's DC05, And if you flip that, that's 05 DC, and that comes out to 1500, decimal 1500. So it's halfway between the 1000 and 2000 range. So the channels that are not used show 1500. So that's the data coming in, so we know what's going on. So now we can start writing some code for the microcontroller. Okay, I'm going to go through the 6 functions or 6 channels on this transmitter. So I start with the joystick. So this is channel 1. You can see it on display. This is channel 2. This is channel 3. And this is channel 4. And the 2 pots. This one's channel 5. And this one's channel 6. Now I could modify my transmitter for 10 channels to add on the 4 switches, but then I would need to get a 10 channel receiver. So that's the functions that we have on this transmitter, the 6 channels. Okay, so now I gathered all that information about the packets coming out of the receiver over the IBUS link. We could decode those packets using a microcontroller. So I have the white wire, which is the IBUS link, connected up to the UART of the PIC microcontroller on my Scamp3 board. And we could decode channel 3, which is this joystick here. So if I move the joystick, I have it sent to the 16 LEDs on the Scamp3 board. And it's pretty responsive. So I could decode any channel and feed it to the 16 LEDs. So next I'll decode this pot here. This is channel 5, and I'll decode that to the 16 LEDs. Okay, I'm writing some code that will decode channel 5, which is this pot here. So if I turn the pot all the way from minimum to maximum, you can watch the LEDs on the Scamp3 board. So we could decode any of the channels, any channel from 1 to 6, and we could get the values, and we could use that in a custom remote control application. So next we're going to have a look at some code. Okay, I have TerraTerm up and running on my computer, and it's connected to my Scamp3 board. So I'm going to run some code. I'm going to demonstrate how we could decode all 6 channels. So my program is called main, so I'll run it. And there's all the channels, 1 to 6, and then from 7 to 14, they're not used, so they're giving out 1500, and at the very end we have our checksum. So if I move my joysticks, my channel 1, you can see channel 1 moves, channel 2, go over to channel 3, there's 4, and then the pot is 5, that's the first pot, from 1000 to 2000, and then the second pot, channel 6, 1000 to 2000. So now we decoded all 6 channels using my program called main. So now we could use that in our application. Okay, here's the code running on the Scamp3 board, and it's written in FlashForth. So when you're coding in Forth, the first thing you do is you write all your tools. Now tools are little chunks of code that help you program. So the first word here we see is bars. That's how many LEDs we could turn on the Scamp3 board. So 5 bars would be 5 LEDs. And here I created a buffer called IBUS, and I'm allotting 30 bytes to that buffer. Now remember, a packet has 32 bytes, but if you take off the header, we have 30 bytes left. This sets the baud rate of the microcontroller's UART to 115.2K baud. This clears the buffer of the UART, and this detects if there's a byte in the buffer of the UART. Now the next word is wait for hex 2040. So as the packets are coming in about every 5 milliseconds, it's gonna try to find a hex 20 and 40 bytes in sequence. If it sees that, it knows that's the beginning of the packet. The next thing it does, it takes the next 30 bytes and puts it into the IBUS buffer. That's our channel data. Then it's going to flip those bytes, because remember, the bytes coming in are low byte and high byte, so we have to flip it so it's high byte and low byte. And it will flip them and it will print them out. Channels 1, 2, 3, 4, 5, and 6. So here's our main word called main. So the first thing it does, it sets the UART baud rate to 115.2K baud. It prints 1, 2, 3, 4, 5, 6. That's our channels. It hides the cursor. And then we go into a begin and until loop. Now this is running continuously until I hit any key on the keyboard, and it will come out of this loop. So the first thing it does, it clears the buffer of the UART. Then it sits in a loop waiting for hex 2040. That's the beginning of the packet. And when it sees that, it's going to pull in the next 30 bytes. It's going to flip those 30 bytes and print it out, and then go back to the beginning again and do this over and over again until we hit any key. So that's our program there. It's called main. It's pretty simple. You run that, and we could see all the channels from 1 to 6 of our receiver output. Okay, so now you know how to decode packets from an IBUS receiver. Now if you're building a drone or an airplane or a glider, the simplest thing is just to plug your servos into the receiver. But if you're doing something custom, then you could go into the IBUS. And I've done some custom remote control applications where I would decode the packets, and then the output of the microcontroller I would use Modbus, and I would feed that into a PLC. So now I'm controlling the PLC by remote control, and if you do that, the sky's the limit.